When we look at global shipping, attention always drifts toward massive container vessels crossing the Pacific. But the logistical reality of Indonesia is entirely different. This is a fragmented nation of over 17,000 individual islands, connected by thousands of miles of water instead of contiguous land routes. To keep the country moving, Indonesia relies entirely on an immense, highly specialized domestic fleet of inter-island vessels. Because strict national cabotage laws dictate domestic sea trade must be carried exclusively by Indonesian-flagged ships, the active domestic fleet has grown to well over 30,000 vessels. The vessels populating this fleet are highly specific. You'll find shallow draft bulk barges carrying coal, and thousands of sturdy harbor tugs, and utilitarian row-row passenger ferries built to seamlessly connect islands like Java and Sumatra. The physical geography of the archipelago requires a massive, localized concentration of active steel, a vast fleet of localized ships engineered for routes they will never leave. Many of these ships were originally purchased secondhand from Japan or Europe decades ago. Now, a significant portion of the fleet is operating past 25 years of age, and thousands of vessels are failing their rigorous structural surveys. This chart shows the market failure ship owners face. The logistical cost of preparing and towing a small, unseaworthy ferry across the ocean easily outpaces the actual scrap value of the vessel's small steel hull. That negative margin makes it economically impossible to export these aging ferries across the Indian Ocean to the traditional, unregulated ship-breaking beaches of South Asia. With no profitable exit strategy, operators quietly withdraw the ships from service. They are frequently abandoned by their owners to sit as decaying ghost vessels in obscure secondary berths and shallow coastal rivers. As these aging hulls slowly degrade in the water, they risk leaking residual heavy fuel oils and toxic lubricants directly into pristine coral reefs and vital fishing grounds. The geographic isolation that required this fleet has resulted in a toxic, localized accumulation of end-of-life steel with no obvious disposal route. The solution to this accumulation is found inside the major maritime hubs like Batam and Surabaya, within the advanced, heavily engineered infrastructure of the Indonesian multi-purpose shipyard. Historically, these massive shipyards relied on a strict two-pillar business model. They built brand new vessels, and they repaired existing ones during scheduled dry dockings. To process the aging domestic fleet, these facilities integrated a highly lucrative third revenue stream, domestic ship recycling. Because these yards are already equipped with heavy-lift cranes and reinforced slipways, they can deconstruct a vessel using the exact same precision engineering used to build it. The spatial efficiency of this process is absolute. A yard can dismantle a scrap ferry on Monday and use the exact same slipway to assemble and launch a brand new tugboat on Friday. By alternating seamlessly between construction and destruction, shipyards secure continuous cash flow, insulating their operations against severe global downturns in the volatile new building market. Processing the domestic fleet locally solved a massive environmental crisis while simultaneously creating one of the country's most reliable industrial opportunities. This shift relies on a strategy academics call cleaner production. Hazard containment is physically engineered directly into the shipyard's foundational infrastructure. Unlike the porous tidal mudflats of unregulated breaking beaches, ships here are dismantled on heavily engineered, impermeable concrete slipways. Advanced built-in drainage channels actively capture all contaminated runoff during the cutting process. That captured water routes directly into specialized on-site chemical treatment plants. This guarantees that zero toxic residue leaches into the surrounding groundwater or the adjacent ocean. Working on solid concrete allows yards to deploy heavy hydraulic shears and mechanized excavators, drastically reducing reliance on highly dangerous manual oxyacetylene torch cutting. The Indonesian Ministry of Transportation actively enforces this transition through BKI, the state-owned National Classification Society. BKI surveyors conduct strict audits of these yards to ensure they possess certified hazardous waste management protocols before granting any recycling permits. This graph shows the human impact of eradicating informal, wildcat beach scrapping. Moving operations from the beaches to mechanized shipyards correlates directly with a 90% reduction in severe worker injuries. Indonesia is proving that ship recycling does not require human sacrifice. The physical risks of deconstruction are systematically neutralized by the disciplined application of modern industrial engineering and a strict legal architecture. The ultimate catalyst pulling these ships out of the water is Indonesia's explosive economic growth, which requires an insatiable, continuous supply of high-tensile steel. The country is currently executing one of the largest infrastructure projects in modern history, the multi-billion-dollar construction of Nusantara, an entirely new capital city being built deep in the jungles of Kalimantan. To feed this urbanization, the government treats the aging domestic fleet as a floating strategic reserve of premium raw materials. It completely bypasses the need for expensive, carbon-heavy imported steel. The pipeline is highly localized. Scrap steel harvested from dismantled ferries in Batam and Surabaya is rapidly transported to nearby local re-rolling mills. There, the thick hull plates are heated and stretched directly into the exact structural beams and ribbed construction rebar required for the new capital's high-rises. Retaining hundreds of millions of dollars of raw material value within its own borders heavily shields the Indonesian economy from the volatility of global iron ore prices. It is a perfectly closed-loop system. The exact same steel that once transported Indonesian citizens across the violent waters of the archipelago is reborn to physically support the concrete bridges and towers of their rapidly modernizing cities. But every ship, no matter how carefully dismantled or highly regulated, eventually faces the same final moment. Join me next time for the series finale, The Last Cut, as we document the exact, inescapable structural severing that erases a commercial vessel from existence.